like my own little mini personal dance party every time. So good morning or good afternoon, depending on where you're joining us from, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. If you're joining us for the first time, we're all about bringing conservation, adventure, and science into classrooms around the world. And I just want to say a huge thank you again, all our teachers live and on YouTube. I know it's an odd time to be a teacher, so we really appreciate you tuning in as we continue to showcase and celebrate such amazing people and places around the globe. So this month has all been about careers in STEM. We've done everything from baby sloths eating flowers to chemical engineers. We've gone out into the universe and close to home, all sorts of really, really cool stuff. And today is no different. We are crossing the pond yet again, joined in London, England by Holly Boothroyd, and she is a Microsoft software engineer. She's going to talk a little bit about her career and her journey to get to where she is today, and her key role as an advocate for diversity and inclusion in STEM. I hope you guys are as excited as I am. We've got already over 300 kids tuning in on YouTube and live, so it's a full house. Welcome into all of you, and thank you so much for joining us today. Holly, take us away.
Hi, yeah, it's great to be here. I'm super excited. Just sort of as you mentioned, I'm Holly. I am a Microsoft software engineer too on the Cortana and Windows team that's based out of London. I'm originally from Seattle, hence why I have an American accent, but I moved here 6 years ago. I'm super excited to talk to you about my journey, the different kind of technical explorations I've done across a few global products, and a bit behind the scenes of how we actually go about creating these products and being a software engineer. So let's get started. So for me, my interest in tech really began when I started playing games like Halo and Fable on the Xbox console from like a really young age. For me, it seemed really cool to be able to create the games that I was playing and kind of make my own so that I could share them with other people. And so as I was growing up, there weren't very many resources out there for young kids on how to learn how to program. Certainly nothing like there is today. But one of the things that really stands out in my memory is that during this book fair of all places, I found a game creation game for kids. And so it was really the perfect way to kind of get my mind thinking about game design and really what goes into actually creating a game. So when I got a bit older in high school, I took a C++ games programming camp at a local university. Now, some of you actually might have heard of this university either directly or indirectly, because if you know the game Portal by Valve, Valve's the one that create games and also run that Steam PC games platform. Well, it was actually DigiPen students who created the very first version of Portal, and then they ended up selling it to Valve. So as a student getting to try out their games coding camp, I actually got one of their very original copies of the original Portal game. So it was a pretty cool experience for me to be able to learn from like such a good university about gaming. Now, if you guys know anything about programming or not, C++ is quite an intense language to start with, so it was a bit challenging for me at the beginning, but thankfully with a bit of determination, I managed to make my first video game. So I felt like I was really on the track to like actually creating the games that I loved playing. But of course, the challenges and being a woman in tech, I was one of only a couple girls in the classroom, did really make me wonder whether or not engineering specifically was the career for me. So after a break from programming for about a year, I decided to take Java and web development classes in high school. So the Java and web languages are much nicer to start with. So the concepts clicked a lot more, and I started being able to really build some cool programs. And when I was looking at what my next step after high school was going to be, I was really inspired by kind of the challenges and infinite possibilities for impact that you can have in tech. So I decided to take the plunge and move from Seattle to England to study computer science with business at university. And this is really where I first started to find my tech community and meeting those close female techie friends that I never really had growing up. And it was this community that inspired me to want to share my love of tech and help others find their place in the industry. And so now during university, I did a year-long internship working at Microsoft in London on Paint 3D. So just for those who don't know, undergrads in the UK are a little bit different than how they are in the US and Canada. So they're only 3 years long. There's no such thing as a prereq class you have to take. So you start your degree right away so you can finish quite a bit quicker. But there also gives you the opportunity to do a year-long internship between your second and your final year. And so that was one of the really big reasons that I was drawn to the UK, was for this placement year. So Microsoft was the first place I applied to, and thankfully I ended up getting the job. And I was put to work on a project that I honestly did not even know what it was until the very first day that I had arrived. So Paint 3D is all about democratizing 3D creation for the masses. And now it's used by tens of millions of people monthly. So there's no sound for this video, but I'll let it play in the background. But Paint 3D is basically feeding into this overall growth of 3D gaming, virtual reality, but also it considers really like how people think and learn. So like our minds are really used to thinking in the 3D world. That's where we exist, of course. And so we understand concepts a lot better when it's presented in 3D. And we're able to kind of take that information in a lot better. So Paint 3D is a tool for creators and gamers, but it's also a tool for teachers and those in businesses where you need to just visualize information. So one of my favorite stories is about how a classroom in New Zealand actually used Paint 3D to teach these Maori stories and their history through 3D, and was really able to kind of start to engage their actual stories in new ways. And what was really special about Paint 3D is it was looking to accomplish something that hadn't really been achieved in the 3D modeling community before. So it's this accessible 3D creation. And this is really achieved by stripping away this really long list of kind of intimidating terms. And so it was quite a feat of just both engineering, so being able to strip these away, make it simple, make it usable for someone who knows nothing about 3D. But it's also such a big feat of experience design, like user experience design and that. And so it was this combination of the engineering and design that makes Paint really successful and actually usable for kids who are really tiny and all the way up to our favorite golden oldies. And so this is why it's probably one of my most proud projects to have worked on, because now it is really enabling people around the world to create in 3D absolutely free, because it's on every single Windows 10 device. But after Paint 3D, I did another 3 months as an intern, but this time I moved back to Seattle and I worked on the Xbox team. I can't even begin to describe to you how excited I was to work on Xbox. It was really this realization of a childhood dream for me to be able to work on this platform that was the one that sparked my love of technology. So I basically had this unreal summer of working on features to help make Xbox really like the home of the best gaming community across all of their platforms. So that's things like Xbox, PC, mobile, VR, mixed reality, all of these things Xbox has kind of a stake in and wants to be kind of a better platform for. So one of the features I added was the ability to connect your, your ability to connect your Facebook account while you're playing games on your PC or in virtual reality with your Xbox account, so you can actually try to find some of your friends. So now Microsoft has always had a really big gaming community on Xbox Live, and in the push to kind of make gaming for everybody, they really wanted this feature so you can actually connect your friends without actually disrupting your gameplay. And this is especially important when we start to look at things like VR games. So this is really, again, future thinking gaming technology, still understanding the right way to interact with these things and what the best experience is that we can provide. So for stuff like this, jumping in and out of gameplay in VR when you have a screen so close to your face can be quite jolting. So we really wanted to minimize any kind of movement or things like that. So bringing this experience into the game made the feature a lot more accessible to people, and it improved their kind of overall experience. This feature I was pretty excited about was actually first rolled out by Minecraft, which was the largest game ever at the time. And I had actually finished my internship by the time that it ended up making its way through all the rounds to finally be released. But my manager got in touch with me being like, yeah, it went perfectly. There was no questions. And so for me to be able to ship something as an intern on such a big platform as Minecraft without any issues was a really cool thing for me. So after my summer, I ended up receiving grad offers from both of the teams, so my London one and the one in Seattle. And honestly, in a bit of a surprise twist, a bit of a surprise to even myself, I decided I wanted to continue working on my London team, partially because I wasn't really ready to move home yet. But also because I knew I had this really amazing growth in London and kind of impact potential that was happening on my team. I know that one day I'll get back to games, I'm sure of it, but for now I'm really enjoying kind of exploring the different technologies that are being created in London and kind of getting to know the industry here a bit more. So now for the last 2 years, I have been working on Microsoft Search Assistance and Intelligence. We're really using intelligence to help users be more productive and focus on making their biggest impact. So one of the big things that my team works on is the Cortana in Windows app. And we're really trying to help define how to best interact with digital assistants, whether that's through voice or text, things like that. And so it's quite an interesting challenge because it does lie at this intersection of a technical challenge, but also a human behavior challenge. So when we look at the market, there's these commonality of things like home speakers or mobile digital assistants. But really users are actually only doing simple requests like, what's the weather or set a timer. And so there's an opportunity for all the people in this space to really expand it and make more kind of big impact features. And so as I share a bit more about digital assistants and creating products, I'm going to jump between a few digital assistants to kind of show how we're all still exploring and learning in this space. So when you're looking to actually build a new product in an emerging space, user research is super key in understanding your users, creating the right features, and building in adoption. So when we're looking at research specifically about digital assistants, there's actually a few things that stand out. So for me, kind of amusingly, people had higher expectations of what digital assistants could do than reality. I'd like to think it was Hollywood influences like Jarvis and Iron Man that really raised people's expectations. People are really looking to put in this minimum effort when interacting with a digital assistant when you're trying to accomplish a task and then receive the maximum reward in return. And secondly, people are really looking for one central location to manage their different tasks and components. It's got to be simple and intuitive. There has to be a low learning curve. Third, people really enjoyed relevant, proactive information. So let's take an example in maybe a home digital assistant space. You could have a utility example where maybe some usage alert information is given to the user when they're about to hit their limits on their water usage or whatever it might be. Just giving them that proactive heads up information where they want to be is what people really enjoy. And finally, and unsurprisingly, security and reliability are obviously a big concern. People will do things the long way if they don't feel confident in your feature and whether it'll work all the time or what that expected outcome is. So when we look at the data, we can see things like people are really only willing to make low monetary, low risk payments through digital assistants. So things around the size and kind of risk of ordering a pizza is fine. But something like paying bills, where it's quite expensive and can really go wrong if it goes wrong, they just did not feel comfortable with. So then with this research and user data, then we can actually start to transform this into actual feature sets. It's good to lead with a kind of a problem-first approach, as opposed to looking at the technology and just trying to fit it in where the customers are. You're going to be a lot more successful if you look at the problems and then try to create the technologies on the back of that. So one approach people use is this kind of core bets and moonshots split. So I'll go over that and just kind of give maybe some examples on what those kinds of things could be. So with like core features, you could say that they make about 70% of that feature set, and they're really the ones that are satisfying the job description. These are things that people are doing frequently, like setting reminders and checking the news. But here's where we can start to add some value. So for some people and some tasks, people will have a different preference on how they want them to be accomplished. So maybe they want something like to read it instead, or watch it, or listen to it. And so as a digital assistant, there's an opportunity here to start to explore this kind of customizing information delivery to give that kind of improved experience. We can also start to use context to enhance our responses and make them more relevant and impactful, which is really what we're going for here. So if we take something really simple, like I've kind of mentioned a couple times, like tell me the weather, handy on itself, but most of the time we're looking to accomplish something with that information, or we're looking to do something with that information. There's a reason why. So a response to it could be improved if you were a digital assistant, just like a real one, if they reviewed the calendar of the person to understand why this person might be asking about this. And then we'll be able to provide kind of additional recommendations, like maybe how warmly to dress, or if they need to leave earlier to get to where they're going on time because traffic might be bad. Things like this. It starts helping provide that extra value and gets people actually where they need to be quicker. So next are the bets. These make up about 20% of your feature set, which are not in market yet, but potentially could become really core features. So these are things you start to look for where you can find, like, add value in tasks that are difficult or routine and can help reduce all this decision-making time. So some of these tasks will also be the ones where the user will know their hands will be busy, and so we can start to provide additional value maybe by using voice instead. This is where that kind of combination of like voice and text and what is most valuable and useful where starts to come into the conversation. So if we use an example on Cortana, for instance, maybe a problem I face fairly regularly is trying to find the best time to meet with someone at work. So I probably spend 5-10 minutes a day or every single time trying to find a good meeting slot. And this is where something like a computer or Cortana can be really, really helpful, because they can be the ones that automatically find the slots, make the recommendation, and when I give them the go ahead, and then book it for me. And so that starts to take that task that would have taken me 10 minutes several times a day down to just 1 minute. It's really easy, and that starts to become the natural place to accomplish that task. And finally, we have our moonshot ideas. These are the kind of the crazy ideas that have big risk, but potentially big reward. They focus on global challenges that have the potential to change lives. So I'm going to use an example from Google for this one. So when they started to look at the data, they saw that speaking a second language is really becoming a global challenge. So there's like 253 million immigrants around the world, and a 50% increase of the total number of international migrants since 2000. And so it makes sense that they would add some kind of translation feature into their products. And now this functionality is helpful in and of itself, but it also goes that step further and really starts to enable those in countries with lower literacy rates to start to share and absorb the knowledge that's available on the internet, because they're able to accomplish tasks through voice. So this is a good example of how it's really helpful to lots of people, but it's also really trying to kind of enable and make Make this technology more accessible. Bring technology to people who didn't have it otherwise. So now once that's all done and sorted, we've done our research, we've figured out what feature sets we want to do, we have a whole team that's necessary to bring these to life. So I work with a whole host of people. So typically I work with a lot of project managers, various designers, test teams, user research teams, things like that. And we use all of our combined strengths to understand what the problems are the user's facing. We want to create these beautiful, usable designs and actually then implement those designs so they can ship to millions of people around the world. And so now my team members are all over the place. So a lot of them, of course, are with me in London, but I work at an international company. So it means that I work with people in Seattle, San Francisco, Japan, China, Israel, Norway, India, Costa Rica, Mexico, and even Nigeria. And this diversity of talent is super important because it means that we can actually learn from our different perspectives and experiences and be able to design products actually built with everybody in mind. So now what does a software engineer actually do? It's my job to basically take the spec that I'm given, usually something a PM will write something to a project manager, will have a task they want implemented. A designer will have a design that matches with that. So I'm given that spec and I basically need to turn it into code. And so I'm going to go from a really basic level, just for those who don't understand or have never really heard about programming. But basically, code is just instructions for me that I write out in programming languages so that the computer and I can both understand it. It's my way of telling the computer what to do. So programming language is just a tool that a software engineer uses. But simply just typing out the code is really only one part of my job. Being a software engineer really means that a lot of my work is mental. So I need to think a lot about the overall architecture of the solution, a clean, performant way of implementing it. I need to handle the edge cases, protect against bugs, and again, make sure it can be used by millions of people. That robustness there, shipping at scale to millions of people is a challenge in itself. It means that small errors, when used by millions of people, that error is starting to now get hit by thousands of people. So now, while engineering might not appear maybe as creative on the surface as maybe some other disciplines, there's actually a lot of creative thinking that goes into like creating good solutions. And it's all of that thinking that ends up boiling down into the actual programming of the code that I write. So I wanted to take a quick look into programming in case, especially if you haven't seen it before. Scratch, this is just Scratch. It's a program I think originally created by MIT. And it's a good way for people to basically kind of learn programming. So you can see in this GIF that basically when I press the play button, the instructions execute and this cat responds. Scratch is block-based programming where you basically just drag and drop different kind of components of a programming language. And like I said, it's a way for people to start understanding these concepts of programming. Because these instructions and these fundamentals that are used here in this simple program is basically the same as in a text-based language. So if we break this down just a little bit further, you can start to see the different parts of this. So we have our conditional statements that run instructions based on whether something is true or false. We have loops that repeat a behavior a certain number of times. And we have like methods or functions that basically wrap up actions or other things to execute. So now if you were basically to take this program and create it in a text-based language, you're going to start to find a lot of the same parts. Let's take a look. So now we have that same Scratch program with its equivalent implementation in a programming language called CSharp. So if you take a look at that CSharp code, I'm kind of curious, can you find the different parts that match? So you can start to see that there's that conditional statement, that if-else block. You can start to see that for loop that increments a counter to track how many times to repeat running its contents. And the methods or functions that are like that random num or print or change color. Those are the methods. And so it's pretty similar to that Scratch code, right? So it's essentially the same parts, just written slightly differently. So the concepts and the thought process are the same. And so this idea applies even further. So just as it's easier to pick up a text-based language from a block-based language, it's also easier to pick up subsequent text-based languages after you learn your first. Because largely you just need to know the syntax, which is essentially just how you write it. So there are a bunch of different programming languages out there, and each of them have their different strengths and purposes, which make them both versatile and ideal for certain projects. So for instance, you'll see a lot of these like C-based languages, so like C, C++, CSharp. These are used in a lot of video games. But these languages, so they're similar, but they're also kind of vary in their like level of control you get over things. So the more control you have, the more complicated these things tend to be. So these C languages, they're used for video games, but they're also used in a whole bunch of different applications as well. So things like artificial intelligence, machine learning, and I've even used them for Paint 3D, Xbox, and Cortana in Windows. So Paint 3D was made in C++, Cortana in Windows and Xbox was mostly C#. And so once you start to learn a language, it really opens you up to all of these like whole world of opportunities. Each language gets easier and easier to learn, and it just starts to become a lot more fun the more you know. So it was actually after, so I mentioned I did C++ on Paint 3D. And so it was actually after that when I did my internship on Xbox and when I first did C#. And I remember thinking about like 2 weeks into my internship, like, oh, wait a second. I'm doing C#. I had not once ever tried to learn it. It was just something that you see the language. It's so similar. The concepts are so the same. You see what other people have written, so you quickly can pick up exactly how to write this thing. So it was super fun for me to be able to actually just transition so smoothly from one language to the next. And so I would say to all of you guys, codings might seem hard at the start, especially when it's not something a lot of people learn for many, many years. But I encourage you to really try it out because it is so much fun. Like if you think about it, it is one of the few jobs that people actually do in their own time for their own projects. And what's so different about this field is that you can learn to code and be an engineer today. So there's so many different kind of like fun and free ways to start bringing your ideas to life. And I've been really inspired by it because you can create almost anything you can imagine out of just nothing but your mind and a computer. So that's me. I've flown through this. If you want to get in touch, please do. I think probably one of the easiest ways to get in touch with me is through my Instagram, HerHelloWorld, because that's where I talk a lot about getting into the technology industry and any advice that I have for it. That's me.
Awesome. Well, Holly, that was a ton of fun. And not just because it was a great presentation and your enthusiasm was infectious, but for me on YouTube in the chat bar on the side, half my fun in most of the programs is making sure kids are on topic. They're not talking about their gamer tags. They're not talking about their favorite things. And this one, it was totally on topic. So we've got a bunch of kids that are now connected in all sorts of gaming thanks to you. So way to go. That was awesome. If you want to come out of screen share so you can see us again, have a bit of a conversation, go for it. I'm going to say a huge welcome again to our classes in BC, Texas, Alberta, Ontario, 10 other full classrooms on YouTube in addition to our ones live. So 350 kids across the continent. Welcome into all of you. And yes, let's dive in. I'm going to start with a question actually from YouTube, and then we're going to go to our live classes in just a minute. Miss Quayle Blyer's class, so they're joining us online. They wanted to know, you mentioned that you work with people all around the world. Is there a language that you use with all these people? Like, is it English that you use to communicate with people? Is it coding languages? How do you keep in touch with people worldwide?
So for the most part, it is just English. Conveniently, a lot of the people that we work with do all just speak English. I know locally, if you're abroad, so like our German team, They mostly speak German when they're just with them, but everybody for the most part just speaks English. So we're a little bit privileged in that point, but it works out.
Cool question, guys. All right, let's go to Simcoe County. Mr. Atkinson, if you want to start with a question, come on in. Just demute that.
Okay, hello, Holly. Thank you very much. That was very informative. I have my virtual class here on the side, and I have Leiden with a question. Leiden?
Okay. With your experience designing part of the Xbox, I wondered how all of the different design people communicated successfully to build the Xbox so it worked well before it was sold.
Wow, good question, guys.
Yeah, so this one was actually pretty cool because it was a little bit different from how my design team worked on Paint. So I'll share that quickly. So on Paint, we were very much kind of a standalone project. We had our designers. My designer sits literally right behind me. If I ever had a question, we basically just swivel my chair around and I'd be able to speak to them. And that was nice because it was a standalone. For Xbox, because they work across so many different surfaces and there's a massive team that goes behind Xbox. For them, they had a whole design floor, so everything could be really like synchronized. So they were actually above us where I was working, and we're able to we just basically set up meetings to be able to talk about these designs. And so what exactly happens on the design side, I'm not as informed on, just because I'm not a designer, but generally they sort of communicate by being all in one place. Being able to work across all of these different surfaces.
Cool. Cool question, Lyde. Thanks for kicking us off with that, man. All right, let's go to Mooresville, North Carolina. Miss McGrath's class. If you want to demute your mic and come on in, you're good to go. A note for all our teachers, actually, you can all demute your mics the way StreamYard works. We only hear you once I bring you in, so you're all set to unmute those mics. Miss McGrath, go for it.
All right, so I have a question about the Oculus VR products. One of my students, Bowen, wants to know if you ever worked at all on those.
I think you muted.
Nope, you were set.
No,
Yeah,
so Oculus is made by Facebook. So I have not specifically worked on Oculus stuff, even though it is very cool. One of the teams that is actually based in London with me, they're the HoloLens team. And so I know a lot of the times I'll go over on their side of the office and speak to them about all their cool VR and MR related things. But for internally at Microsoft, the things I was working on, Microsoft has their own, I guess, so Windows 10 sort of mentioned on one of the photos, if you read the little blurb. Basically, you program for Windows 10 or you program for Windows, it'll essentially work on a bunch of different platforms. And so when it comes to the VR stuff, Microsoft sells Windows, but they do not create their own VR headsets. So we have third-party headset people who basically use our software. So the one that I was using at the time was one that was a mixed reality headset made by Acer on Windows 10. And it was really cool because it was both really affordable. So that was a big thing, especially on like Oculus, is very expensive. But also it does inside out tracking. So you don't need to have a million sensors all around your room. You can basically just put the headset on, use the controllers. That's sort of, I'm not sure if you can see in the photo, but there's lots of little dots that are all over the handheld like controllers so that you can start to actually do the sensing.
Cool. I think third-party headset person should be on a business card somewhere. Let's go to Miss Martin's class, joining us at the French American School in Princeton, New Jersey. Welcome in, Miss Martin. Come on in and go for it. Hi, guys.
Hello, thank you. We're in person here in Princeton, and the kids don't but you. I mean, you've done a great explaining everything, but my question is, if my students are familiar with Scrap, what written language, programming language would you recommend for them to try?
Yeah, so I would say from my experience, Java is a good one. So that's what I did, I guess, second. Java is really nice. And if you're doing AP computer science, then I'm pretty sure they do it in Java still. At least that was the case when I took that class. Otherwise, a really common one is Python because it's it's very beginner friendly and it's very applicable to so many different use cases. And finally, if you're not going to go down maybe I guess a normal kind of app language, so like something like Java and Python, web languages are really good as well. So just even doing a basic website, HTML, CSS, that kind of stuff, that's a really good way of starting to kind of get some experience with the web technologies.
Yeah, I'm really glad we asked that question, Ms. Martin. So many other teachers have shared that on YouTube, so that was awesome. I'm going to go back to YouTube, and then I'll come to you, Ms. Smith, in just a second. So Ms. Wu's class, they're joining us in Houston. Welcome back, Ms. Wu's class. They want to know what's the first game you created. You didn't actually say what it was, and what's your favorite game of all time?
Yeah, so my first game I created, it wasn't very good, but it was fun. It was based off an English sketch, so I don't think any of you will have heard of it before, but there was a sketch series by a woman named Catherine Tate in England, and so I basically just made this game where you kind of moved your mouse and tried to avoid things flying on the screen and pick up power-ups, things like that. But in terms of my actual favorite game, I feel like, so the games I play, the games I really enjoy are Halo, Assassin's Creed, Far Cry, and there's some other ones that I'm now forgetting, Fable, of course. And so I'd probably say, given Halo's been really with me for many, many years, I started playing far too young. I was like 6. It's a mature rated game. I was told that all the enemies were sleeping and not dead. But I'd say probably Halo's really stuck with me, so it's got to be my favorite.
Yeah. It's when they explode and fly off the cliffs that you know they're really, really sleeping. All right.
I used to play with my dad, and so he'd be like, oh, they're just asleep. And I was like, we really need to go before they wake back up again.
They're scary. There's a lot of them. It's okay. My dad had me watch Terminator when I was 6, so we're in the same boat. Miss Smith's class, they're joining us in Mississauga. And again, before we went live, Miss Smith's class said that, like, of all the programs of the month, like of all the epic conservationists, whale shark swimmers, baby sloths, their class wanted to be here for software engineering. So Miss Smith, come on in, ask us your question.
Hi, thank you so much, Holly. That was an excellent presentation. I actually have a whole bunch of questions from my students, but I'll start with the first one from Armand. So these students are mostly grade 8. They're all grade 8, actually. So when they're thinking about high school, what sort of subjects should they be taking? They'll be doing Java or some other sort of maybe Python coding on the side, most likely. But what sort of academic subjects would be really essential?
So for me, I would say physics. I took physics because I really wanted to use it in games, and the kind of math is just really helpful. I ended up doing calculus all the way to the end of high school. I would say it's relevant for certain parts of the industry, so it was really helpful going into university and into certain roles. It gave me a lot more flexibility having that extra math knowledge. I wouldn't say it's required, though. So I'd probably say physics, maths, if you can't do any computer science classes, that would be ideal. I'm trying to think of what else there is even available, but I'd probably start with those two. Those are going to give you kind of the biggest maybe step up when you're going to go try to move on forward.
This is really good. I'm so glad we're getting these questions live. Again, on YouTube, they're reflected all over the place as well. So many have kids that are teen. They love games. They're like you. They had this backdrop in their lives, and they want to know how to turn it into a career. So the fact that we get to talk about this is fantastic. We're going to go to 2 live classes where there's kids in a classroom too. Miss Martin's class already showed us that, but Miss Goraski, if you guys want to come on up, go for it. You guys are joining us in Thunder Bay, Ontario. Come on in. Hi.
Leah's going to come and ask a question for us.
What was your hardest challenge and your easiest code?
Nice.
My hardest challenge and my easiest code?
Yeah.
Yeah? Ooh, okay. My hardest challenge. Ooh, that's a tough one. The thing is, I look back on some of these challenges now and they don't seem too hard. They were just hard at the time. I think when I tend to answer this question a little bit less in terms of a technical response. I'd say probably the thing that stands out for me in terms of challenge in my career was honestly just an internal challenge. The fact that I was a woman in tech meant that I had things like, I guess if you might have heard the phrase imposter syndrome. I was just a bit nervous being in these rooms. Wasn't necessarily sure that I felt like I deserved to be there. It's quite intimidating being the only girl sometimes. And so what I was it was quite a transformative experience over my placement year working on Paint 3D, because I came in so nervous to try to impress people that I was so excited to work with. But it was really nice because just sort of going through the process of like getting a task that you have no idea how to do and sort of working with like either your team members or just sort of working through the challenges means that by the end, you'll be able to kind of produce this great piece of work and that you've learned something. And so it was kind of after doing that several times of not knowing something and by the end being able to deliver something that I started to gain a lot more confidence in my programming skills and what I'd be able to do. And I think part of that, honestly, was my mentor. He always would be like, yeah, it's fine. We'll figure it out. And so I've kind of adopted that standpoint now of just being like, it'll be fine. I'll figure it out. All these problems are solvable one way or another. So I think, honestly, probably my biggest challenge was more of just getting that confidence to know that I'd be able to basically accomplish anything I put my mind to. In terms of my easiest thing, though, that's... I do a lot of easy bugs still. Some things are just a one-line code change and you feel great when you submit those.
Nice, guys. Great questions. And Holly, that was hilarious and fantastic as always. We have time for one more question. This is the problem with these programs, is that we have too little time and too much fun being had by all. But we're going to go to one last class for a live question, and then I'll bring up Holly's list of ways that you can get in touch with her that she shared at the end of her presentation again. So if you have any more, you can keep in touch that way. But let's go to Miss Fairweather's class. Hi, guys. Welcome in class. Yes. Welcome in BC. So just mute that microphone and you're good to go.
Thank you so much for your presentation, Holly. It was inspiring and so great to see. Also, side note, thank you for the changes that have been made to Cortana. They're very useful in our inbox as teachers. But we had quite a few questions, but they've been answered, so that's lovely. We have another one, though. What would you like technology to look like when you retire? And that's from Izzy.
Ooh, this is a really good question. What would I like technology to look like? I think right now when I look at a lot of technology there's a lot of cool things being built, but not a lot of people who can use them. And so we've seen things like this, especially it's been exaggerated or exasperated during the pandemic because people have to go home. Maybe they don't have good internet connections. Maybe they don't have a good laptop, all sorts of things. And so for me, I'm really hoping to see, I guess, in the next 20, 40 years is that this technology that we have access to now really becomes a lot more democratized. So people around the world can start to take advantage of it. And I think one of the things that I really love, I don't work in this side of the business, but I think it's really cool is, so Microsoft's cloud system, what we give to our enterprise or business customers is something called Azure. And in Azure, you can get access to a whole bunch of different things that help you do things like computer vision or, I don't know, image recognition, stuff like that. And you can start to do even things with like no code. And so I'm hoping that technologies like that be able to be a lot more accessible so we can start to see some amazing innovations coming out of places that maybe their infrastructure isn't quite as good.
What a cool question, and not one that we get very many versions of in any of our programs. So thank you so much, Ms. Fairweather's class. Again, guys, I know we could go all day. You guys are so enthused. We've had probably 100 questions in the YouTube chat bar, and I know our live teachers could ask so many more. So this is awesome. Thank you guys so much for your enthusiasm. But as Holly said at the end of her talk, you can check her out on social media at Holly Boothroyd with a little dash at the bottom, hollyboothroyd.com and herhelloworld.com. Holly, yes, go.
I would say my Instagram is probably better to do the at HerHelloWorld one. The other one is my personal account, which you'll find zero.
Sorry. At HerHelloWorld.com. You can learn many more stories of what the work Holly's up to. how to get inspired, how to get involved in these careers. Lots of really great options for you guys. So I'd really encourage you to check that out. And then one quick note for all our teachers is a sneak peek. We're literally announcing this today, February 12th through 14th. If you want to hear from almost 50 amazing women like Holly, we are on womenblazetrails.com. It's one of our biggest festivals we've ever run as an organization, so check that out. It's over a weekend. We're running it as a big program for us, so hopefully you guys get a chance to tune in. Holly, this was so much fun. Thank you so much for joining us today. God.
This is great. It's gone so quickly, though. I wish we had more time for questions.
I know. On your website, I'm just curious, while we've got the kids here, on your website, is there a feature where people can share more questions with you? Is that a possibility, or are you too busy?
Yeah, I mean, so maybe not on my website. You can send me an email through my website. Through my Instagram, feel free to honestly just DM me. Maybe every once in a while I do those question stories where I can answer any of your questions there. Honestly, really happy to help. Feel free to just message me anytime.
Awesome. Well, Holly, thank you so much again. And what we do at the end of every one of our broadcasts, I'm going to bring in all our live teachers to join me in saying a big thank you and goodbye. So Mr. Atkinson, Ms. McGrath, Ms. Martin, Ms. Smith, Mr. Thank you.